My name is Minher. Today, with Chris and Samir, we are going to share the experience building a agentic-ready graph. We're going to share how we start and what we learn along the way. So here are the agendas. I'm going to start with the overview of the bookings GraphQL ecosystem and how our platform have evolved. And then I can share some numbers. You can learn about the current status, and I will do a quick 2 demos to show how we support agentic use cases. Then I'm going to pass to Samir, who will share the journey that brought us to this point. And after that, Chris will deep dive to the how we approach understanding the complex schema in Booking.com. And finally, Samir will wrap up with how we keep our platform secure and where we're heading next. So yeah, here we go. Like many other companies, we start with the isolate APIs. Each team, they build and maintain isolate endpoint. And these isolate API were served from a per mono service. And I'm not kidding, per used to be a big thing in Booking.com in the early days. Most of the components built and run on per. And honestly, today, some of them still do. And then in 2021, we create a SIEM GraphQL layer, which proxy these isolate endpoint using GraphQL schema staging and serve a unified GraphQL API on top. The main driver for this was Booking's technical modernization movement. We call it a replatforming project. So that's when our team was formed and to create and maintain this GraphQL layer. And soon later, in 2021, we adopted the federated GraphQL and giving the full autonomy back to the domain teams. And today, we're operating a special API, which is GraphQL MCP server to handle the agentic request. So here is the full picture of our platform. The full picture of Federation GraphQL. Federated GraphQL has become a default data access pattern across the whole organization. Almost all the domain are serving data with federated GraphQL, from flights, cars, from insurance to payments. Every team, most of the teams serving data through Federation GraphQL. And our platform not only serving the regular traffic pattern. For example, the traffic come from presentation layer across mobile and web, from front end to back end, service to service data consumptions. We also today handle the agentic traffic pattern. So in short, we are actually literally maintain a real supergraph. So to give you a sense of our scale and complexity, we are currently managing more than 170 subgraphs. And these subgraphs serve more than 8,000 tabs. I never remember this number, but yeah, this subgraph serve more than 8,000 tabs, serving 4,000 live operation in the productions. And the domain data coverage is around 80% across the whole organization. So yeah, maybe these numbers still not giving you the complexity of our graph. So let's try to visualize it in Apollo Studio. Yeah, like you see, We try to, if you try to understand or get a view how the data is in Booking.com, the first warning coming from Apollo Studio is the size too big to load. But the good thing is Apollo have the filtering we can use, right? We can put a filtering on it, then you can see it start to load. It will take 10 seconds to start loading the data. Yeah, but after you see this, you try to roam in, roam out to get an overview of the data. At some point, you just give up, right? It's not possible to get how the data look like from this schema viewer. So it won't be, I will be curious, I think you will do, how this, complex and massive schema support agentic use case. To answer that, let's take a look two demos. The first one is text to GraphQL. It's about natural language to generate a valid federated GraphQL. So we built an agent, text to GraphQL agent. And in this demo, we simply ask our agent to generate a query to check if user is eligible to access our recommendation platform. So I'm not going to lie to you. This is a real demo, and there is no fast speed added. And it will take like 1 minute to generate this simple query. It's a lot, right? But the reason is simply because our graph is too complex. It's not easy to generate a valid federated GraphQL. So it's clearly not useful for customer-facing flow. No user will waiting for 1 minute to get something back from our website or our app. But it's good for developer. Imagine that if your developer try to query data from multiple domains, and basically you can just structure your data requirement and hit the enter, and you go make a coffee chat with colleague. Then you go back, and you see the valid query there with very clear how to use it, how to put into our MCP server, and this whole process will accelerate the whole time to market for a feature, right? So maybe we can say this is one kind of the vibe coding experience. So the next demo will be more interesting. So we try to ask the agent to book a cheap hotels in London next week for Wednesday. So we are demoing WinServe, and WinServe connected to our MCP server. And behind the scene, you can see that the agent can identify and structure the whole user intent and find correct tool to do the hotel search, reservation creation, payment setup, and payment finalized. Then eventually you will send out a confirmation notification to the users. But in this demo, we are using a task account and all of these running in our staging environment. So no production data is attached. So it's not actually running in live production yet. But you might hear some news from the social media. Recently, like 2 days ago, Booking and OpenAI announced that Booking is available in ChatGPT to enable users outside of European to do the trip planning directly from ChatGPT. So, we couldn't be this current status, even for POC or real production use case. We cannot do, it wouldn't be possible. You don't have a complete graph and a solid end-to-end tooling management framework. So I will pass over to Samer, who will explain the journey brought us to here.
Thank you, Mingge. I will go on talking about the journey about making the agent, making the graph agent ready. If we ask that question to ourselves as technical community, always it's a weak yes, unless someone from higher management asks us if it's ready or not. Yeah, I will explain how we will make it ready for our AI agentic applications internally, and what are the challenges towards it in schema quality related challenges and MCP tooling related challenges. So for agent readiness, there are three things that is important. Schema being discoverable, MCP tools that we registered under our MCP layer are discoverable for AI agents. And last pile is a no-brainer, security, how we obtain the security for the operations for our schema level elements as well. Some issues, quality issues that are quite obvious for every other schema in different organizations. We have problems about naming different domains, name different concepts, same concepts with different naming that creates confusion on the consumer side. We have stale fields. Somebody tries something but leaves it there. Don't delete unused operations or types. Some domains doesn't define their entities in a way that reflects the conceptual data model of theirs, underlying data model. We have many duplications, like duplicate and overlapping types across the domains, and we have some mechanisms to eliminate that as well. It's also something we are looking into carefully with AI. And access controls, yes, we want to make sure that our data, PII data, sensitive data is protected by the mechanisms that we introduced. Mostly GraphQL native directives that we introduced in federation layer. To do so, to eliminate these concerns and make the schema ready, we have introduced a quality assurance pipeline internally. It is creating a feedback loop between our federation platform and subgraph domain owners by running checks against these issues and making sure that people, domain owners, are aware of these issues and taking actions to fix these issues and see the trends as well, like how the schema quality in the subgraph level goes. And even they are prevented to lower the schema quality by the mechanisms that we introduced centrally. They get feedback, they see the trend about their schema quality, they see different elements and problems exposed in the pipeline level and via a engineering UI that we have, and they are disallowed to decline the schema scores. These are the things that we are doing to obtain the readiness of the schema for AI agents, as well for different kind of consumers. We still have traditional UI elements in the company, web, mobile, etc. So a practical thing that I want to share, as long as we have much better, much cleaner schema and increased schema quality, we have seen less design-related support requests coming towards to the federation platform team, and it saved a lot of resources. I wanted to mention that apart from AI agentic readiness for schema, it has more practical benefits to increase the quality of the schema for organization. Makes happy the higher management, less resources to be used for design support tickets and stuff like that. And second side of the things, MCP tool readiness. This is a little bit detailed diagram of how we handle the MCP tool registration flow. I have a little bit more refined steps in the next slide, but overall we expect developers to use a tool that we have introduced, and Chris will explain later, text to GraphQL, to generate their GraphQL queries. which will be operations that we expose under the MCP component that we introduced in federation level, platform level. We run some mechanisms to detect PII data to be sure that descriptions for these operations are structured and good enough for discoverability. And more importantly, after the operation is created, we run the operation and we process the operation and generate the query plan and find out which subgraphs are providing data for this operation and make sure that those subgraph owners, domain owners, have a consent over this operation to be exposed to the AI agents. Because, it might be a subgraph that managing credit cards and they might be a little bit hesitant about security issues and don't want that kind of operations to be exposed to the AI agents. We want to create that feedback loop and make sure everything is going well for agentic applications. Another thing that we did is about how we structured the metadata for each operation that we registered under the MCP tool. Especially input management is kind of challenging. We need to give some information to be able to generate, to be able to handle requests towards the MCP tool, not to hallucinate, not to have struggles about input generation. We put some metadata, we make sure that input variables are flattened and etc. Some other things that we apply in metadata descriptions and management. And another thing, as we see important, predictability of the tools under the MCP. We want to prevent that tools under MCP as product functionalities doesn't overlap each other. And we want to make sure that user prompts are mapped to a single operation and we don't have some kind of ambiguity over there. We use integration tests to be sure that tool to user input, natural language input is kind of mapped and predictable to make sure that agentic applications internally works well and being predictable as well. Yes, we did this schema scoring related stuff to improve the schema quality. We added some registration flow over the MCP and MCP tools management flow we introduced. But we still need AI to leverage to understand the supergraph. And to explain that, I want to call out Chris to move to the next section. Thanks.
Thanks, Enver. So one of the things we need to do to improve, obviously, the schema quality for AI agents and devs alike is building tooling that actually understands the schema, and a large schema at that. Now, our schema doesn't really fit in most context windows of most AI models, and even if it does, it makes things up. Hallucinates. So we need to take that into account as well. So we actually took some low-hanging fruit approaches to see, can we just do something quick to see, can we get the AI to understand our graph, even if it's not the most efficient or the most applicable. We can set up vector databases, do RAG, do all that fun stuff, and yes, I'll talk about that in a second. But let's see if we can do something easy, local, and quick. So the first exploration was what I call query introspection. So let's assume we have a small scheme like this with hotel, search, and user profile. Those are our three routes that we have. What we do is we generate a select star query, so every possible field under that root query. Of course, we deal with the recursion and all that kind of stuff. But for the most part, we generate that. So in our case, we would have generated 3 queries. In our actual case, I think we generate like 500 or 600 queries. And then with that, we can iterate over each one and ask our LLM questions about it. In our case, for hotel data, we're going to see if it does contain hotel information. We can put a tracking file, and we can do things on it. So here we do 3 calls to LLM to get it to work. This keeps the context window very small and terse in most cases. Hotels have a lot of data, but overall, it seemed to prevent hallucinations quite well. And we could start asking questions quite a bit. So from here, what are the use cases that we discovered with this? Well, the first one is more or less, we have query analysis and description generation. Super great on asking the LM, hey, generate me a description of what this query does. And I can feed that back in and create an MR that's MR to fix it and have information about it and the fields that it supplies. Then from here, so target schema creation, and this was the original reason that we kind of approached this. We got asked a question by a team, hey, what information about a traveler, or what we call a user, is in the graph currently? And the answer is, well, we don't know, but let's find out. And so we just did this, and we iterated over it, and we were able to kind of easily identify all of the different traveler bits and information and see how well connected it was. And the answer was it wasn't connected at all. So it was very poorly connected in that regard. But we were able to kind of see, and then with that, we could generate a new schema, a new entities, to kind of create a target schema that we could look towards. And from here, we can also do PII detection. So this really gives us the ability to effectively say, OK, in this context, this obviously means PII. Exposing PII is not bad. User profile on pages like that, that's OK. But we do, for auditing purposes, want to know which queries expose PII. So if we need to track them or do security analysis or things on that, we know where that data is. Now, that's great, but you have to run the LLM like 500 times to get it to work on our graph, so not always the most ideal. So another approach was to kind of look at schema chunks. Can we break down the schema into a handful of chunks that fit within the token size, or the context window size, and prevent hallucinations as well? And here, the first thing that we did was we made sure we understood the graph and could break it down accordingly. So we actually consume the supergraph API in its full form that the router would get, for example. This includes all that good meta information about which fields come from which graph. That's really important for this. And it allows us to tie a lot of things together. And so we built a system that is able to effectively understand the graph and like all the complexities with it. If, based on what I've seen at this conference already, I'd probably build an MCP tool that defines the federation specification and kind of wire it up that way instead. But that was more clever than what I could think of, so we came up with this. But it worked at the end of the day. And what do we do with this? So we take each type then, and we vectorize it. We don't embed it yet, so we don't generate the floating point numbers. But we vectorize it, and we flatten it with the information we think is relevant. This is subgraph, the type name, meta information, and the fields as well. And this is just an example. And we create a huge flat file that we feel fits within the context window, usually about 50–60% of the size. Seems pretty good at preventing hallucinations for the most part. And here, over each of those chunks, we can ask the question. So this reduced 500 chunks down to about, I think, 60 or 70 when we did this. And we can ask the same questions. But there are benefits that you get from this that you don't get from the other. So some of the things that we can see are type analysis. So we can kind of better understand what these types are, what they do. You generate schema insights. This isn't so much from the LLM, but just the fact that you have to understand the graph and how it works. You better understand the connections. How many entities do I have? Who's using those entities? We generated some reports off this to better understand the connections of our graph. We even built a visualization tool that was able to load the graph in for this purpose. It was also completely useless to understand the connections, but it looked cool, which was nice. And then also type similarity. So one of the cool things with vectors is even without LLMs, there are other types of AI, by the way, like natural language that's existed for years. You can do basic comparisons based on that vector space. And that's what we were able to do is we could see a lot of low-hanging fruit and maybe like not the best way of creating types or where they should have created abstract types or things like that. And a basic NLP approach can take that, and it's a lot cheaper to run than an LLM. So we could kind of see that go. And then you could eventually feed this into RAG and do all that stuff if you wanted to as well for more comprehensive type analysis. Now lastly, we've talked a little bit about text to DML. Now this obviously came with a very specific use case, which was take natural language, spit out a GraphQL query. So a little bit different than purely analysis in this case. But we hope to eventually kind of, based on our learnings, do more sophisticated analysis in the graph with this. So we came up with this workflow, which effectively is we embed the schema and a set of sample queries. This is where select star queries come in really important. You can generate a whole bunch off the fly very quickly that are really comprehensive. And you can give them descriptors and information to feed into those embedding models. So then the schema itself is stored in S3, and it's loaded into OpenSearch. And then there's a couple other components that I'll talk about here in a second. So overall, how does this step work? So first, we embed queries in Bedrock. That's the first stage with the schema as well. We then store and retrieve the relevant chunks from OpenSearch. So it's the part that has the schema itself in it. Then the LLM generates a query and retrieves and retries it if it fails. So that's how we have that retry lambda. So that's what's great about GraphQL. We can validate if this query is actually going to work and make sense. So from there, we just return a valid query once it succeeds. If it never succeeds, obviously we return a failure. But this is effectively what we're doing is not guess and check, a little more sophisticated than that. But that's kind of the flow that we're doing for this. And we hope with these embeddings and understanding, we can do things such as more comprehensive type comparison or analysis where what are similar types versus really close types, and understand the domains a little bit better as well now that we have these models in place. With that said, I'm going to hand it back to Sanver to talk a little bit more.
Thanks, Chris. Last bit to discuss to make the graph agent ready, which is security. There are two aspects in the agentic security area that we see as important. Agent access controls and data level access controls. Agent access controls is about, it has two aspects, how much responsibility that users would allow to the agents to take actions on behalf of them, and which data sources agents can access. And another one is data access controls, like more granular level operation or field level in the GraphQL schema, how to obtain the access controls in a complex way to handle agentic flows, agentic request flows in subgraph domains. Looking at this high-level architecture, we have two things here to share. One is the consent aspect, consent scope that we added to the access token that we have, which has like simply consent from users to take, to allow some actions to be taken by the AI agentic applications. So, for example, if our consumer is 60 years old, who is not trusting AI agents and don't want them to manipulate their credit card information, we can disallow that by revoking a consent for that operation for AI agentic applications. And another thing, service-to-service access tokens that we used for AI agentic applications. We have some data sources that only exposes internal proprietary data like financial data, etc. It is not necessarily to be consumed by AI agents. So we obtain that access controls by S2S access control, S2S access tokens concept in our architecture. And as you can see, we have an internal access control platform that we, in every level, use for access token, issuing access tokens and verification, decoding to extract the consent scopes from the token, etc. Coming up to the data level access controls, which is more granular level access controls, we are using a policy directive over there, which is the powerful concept provided by Federation spec, by Apollo router. It is fully supported. By using the elements that I shared here, access token and information embedded in the access token, service-to-service token, and request context elements, which contains various information about the request and client as well, can be used to design complex policy rules and configurations by, again, the same internal access control system that we have, so that subgraph owners can define their complex access policies for their operations and fields, powered by schema-level policy directive that we introduced in our Federation platform. So, yeah, these are the all things to make the graph ready, for sure. But what's next? We want to introduce a hyper-personalized dynamic screen-serving UI as our platform's capabilities, so that we have already started that. We are using graphical concepts to identify and define the layouts and layout elements, and we are applying some personalization and ranking as well by the help of AI and ML models. But to have this kind of fancy user experience, we have some way to go. This is our plan to enable in the next year, potentially, to using GraphQL and using AI in our environment, in our stack. And lastly, another thing that we are working towards is to expose our product capabilities to the external AI agents. Now, mostly we are leveraging internal agents, but we know that it is the way to go. As Minge shared before, we are experimenting for some capabilities, and we open it to the ChatGPT and OpenAI, but we want to extend it and make it consumable by various AI agents, external AI agents. As you can see, now we step towards that, but there will be more to come for this area. These are all the things we will be sharing today. Thanks for listening to us, and if you have questions, we are very welcome to answer them.
If you'd like to ask a question, just raise your hand and I'll run the mic to you.
Thank you. Really appreciate you guys going through in detail. I wanted to understand more about the vectorized approach, where you're chunking the schema and kind of generating that metadata for like what those types represent. I just wanted to understand better what that type actually is vectorizing, and then what does that RAG allow you to do? It seemed like you guys were using some form of like chain of thought or some form of like RAG application there. So just some more clarity around that, if you guys can.
Yeah, sure. So the chunking approach was used to obviously break it down into a little bit smaller things where the LLM could understand a little bit. The vectors themselves, maybe not the best word for that, but effectively what we stored there was the subgraph name, the type name, was it an entity or not, and then I'd have to look at my computer, but then all the individual types that are on there, or the fields that are on there, excuse me. So we use that as a base vector, and then what we could do was, when we did look at RAG for this, and so I have a longer talk about this from the GraphQL conference, so you can look that up on YouTube if you want. But what we did was we did do that for embeddings, and the results were a bit mixed on how well that was effective. We were working on smaller local models just because at Booking we're still kind of getting our feet wet more with building out RAG applications and kind of that stuff. But that's kind of where we wanted to see, okay, is this a valid approach to take? And my answer is probably. And I want to experiment with that a bit more. We worked with another team on the text to GraphQL approach. That wasn't just us, but more people were involved as well, who had more easy access to be able to build vector databases and stuff like that, as they were responsible for kind of experimenting with that.
Yeah, and Apollo did. I mean, yesterday Apollo asked what we're looking for Apollo for next year. I think that's a thing I really want to work with Apollo to enable a fast text to GraphQL from inside. I mean, Apollo Studio directly, because I try to generate the operation from introspection and combine with introspection and evaluate execute from the Apollo MCP. Most of the time on our supergraph is not valid GraphQL. So that's a thing I really want to get from Apollo next year. Yeah.
Yeah.
Great presentation. I would like to understand more on the access security or the security patterns. Like right now, we are dealing with agents. and bots. So how are you adding guardrails to your operations or to your graph?
If I'm not wrong, you're asking from how we add agentic piece to the.
Agentic guardrails.
We are simply using access tokens and scopes in the access tokens. We involve the consent, user consent to the access tokens, and we are making sure that user having consent for AI agents, AI applications to take action on behalf of them for that specific operation. Like if user wants to allow agent to make some updates in their reservations, we get consent from the users at first to enable that in like high level as a flow.
But what about the TTL of it? Like, you know, I created an access token, how long that will be valid for? Because if I have the browser, if the history, somebody can, like again, there are so many, so much details, right? But how are you managing the TTL or ensuring not the misuse of it?
For different clients, TTL changes. For example, like if user updates the native app, we invalidate the token and we enforce them to get into login again. And similarly, if we like have a refresh in the web page, sometimes after a while, we make sure that we are forwarding the page to the login, and we lower the level of assurance for that token to make sure that like user has still consent to that operation, and we are still fresh for that consent on the client side. I don't remember the exact TTL, but yeah, we for sure have like some TTL in general, of course, but yeah, I don't know how much time we add on top of that. So yeah.
I think the shorter would be best to have more consent from the user and then we can go proper.
Actually, in Booking, for the authentication flow, it's combined different layers. For authentication, it's basically about other authorization and consent collection part, and how the data owner use this kind of information to do the actual access control, right? So for the first part, it's the user interaction with the application, the business application, and the application will collect the consent. But but for each request in Booking, we have dedicated team, IAM team, to deal with the user interaction authorization, to issue the token that embed these security information to the token, and this token will pass along in the whole request life journey. And each downstream service can take this information and validate with internal access control platform to ensure that ETL, scope, policy, everything is in play. That's how we work in Booking now. Hope I can answer something. Yeah.
I have a question. So you mentioned that one of the challenges that you encountered was all the duplicate types on the schemas. And I was wondering what was like the solution, and if you change your schema or if you use agents, and how was that journey?
Sure. So the question is effectively, how are we dealing with the duplicate types and what's our journey with it? Well, we just started identifying them, so the journey is still pretty at the start. The goal is effectively to start messaging, understanding what duplicate types we're finding, why they occur. The low-hanging fruit ones, for example, we see some that are effectively layout types that one's for mobile, it's like left image mobile, left image web. Doesn't really make any sense. All the fields are the same, everything's the same. And we want to see why are they doing this, what are the limitations, and understand that before we start going, okay, here's an MR to change all this or fix this up. We need to understand a little bit better about why it's happening first. But we do expect AI will be part of it. AI, we already are starting to work on effectively just bulk adding descriptors to missing queries and fields. Teams can approve those MRs as they want. or edit them. I would think they would probably want to edit them first before they just accept whatever AI generates. But those are the things that we're looking at, hopefully this next quarter and the next few months.